So we're going to look here today at the converse of the Pythagorean Theorem, which is one of your standards in 8th grade math. So what this is asking is, instead of finding a missing length of a right triangle, it's asking you, with these three side lengths, is this triangle a right triangle? So we use the Pythagorean Theorem to determine that. So the first thing you're going to do is change the side lengths in order from least to greatest. That's the first thing you're going to do. So on our example here, we've got the numbers 5, 12, and 13. That is already in order from least to greatest. So we didn't have to do anything there. The next thing you're going to do is substitute those side lengths into the Pythagorean theorem. So the two shorter lengths, the first two lengths, will go in as your legs, A and B, and then your longest length will be your hypotenuse. Okay, so that's why we put them in order from least to greatest. So that's what they've done for us here. They put 5 in as a leg length. They put 12 in as a leg length. So a squared plus b squared equals c squared. So 5 squared plus 12 squared is going to be equal to the hypotenuse squared, which is 13. Then they've done 5 squared is 25. 12 squared is 144. 13 squared is 169. Go ahead and take care of your 25 plus 144, and that is 169, which is what we have on the right side. So because this equation is balanced, this is a right triangle. Let's look at the next example. We've got 6, 11, and 8. Now these are not in order from least to greatest, so we're going to have to rearrange that to 6, 8, 11. Then we substitute that into the Pythagorean theorem, a squared plus b squared equals c squared. Then 6 squared is one leg, 8 squared, 8 is the second leg, and 11 is the hypotenuse, so it goes in for c. Then I evaluate. 6 squared is 36, 8 squared is 64, 11 squared is 121. Then I simplify this side. 36 plus 64 is 100, and then 121 is over here. This is not a balanced equation. 100 is not equal to 121, so this is not a right triangle. So we arrange the side lengths in order from least to greatest. Then we substitute into the Pythagorean theorem. And then last, if it balances, then it's a right triangle, and if the equation is not balanced, then it's not a right triangle. So we'll try that a couple of times. So this is already in least to greatest order, so 1 squared plus 2 squared equals 3 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 1 plus 4 is 5. This is equal to 9. That is not true. This is not a balanced equation, so this is not a right triangle. And I'm just going to draw the symbol for triangle. All right, 6, 8, and 10. Already in order from least to greatest. So 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. 10 squared is 100. 36 and 64 is 100. So this is a right triangle. 3, 6, and 9, already in order from least to greatest. 3 squared plus 6 squared equals Hypotenuse is the longest one, 9 squared. 3 squared is 9. 6 squared is 36. 9 squared is 81. And 9 plus 36 is 45. 45 is not equal to 81. This is not a balanced equation, so this is not a right triangle. Two squared plus 5 squared equals 7 squared. Already in order from least to greatest. 2 squared is 4. 5 squared is 25. 7 squared is 49. 4 plus 5 is 29. This is 49. So this is not a right triangle either. Eight, 15, and 17. Already in order from least to greatest, so 8 and 15 are the legs. And 17 is the hypotenuse. 8 squared is 64. 15 squared is 225. And 17 squared is 289. 64 plus 225 is 289. And 289 is already over here, so this is a balanced equation, and this is a right triangle. (20, 21, and 29). Already in order from least to greatest, so 20 squared plus 21 squared equals 29, the hypotenuse squared. 200 squared, or excuse me, 20 squared is 400. 21 squared is 441. And 29 squared is 841. So 400 plus 441 is 841, which is what we have on the right side after we square the hypotenuse. So since our equation is balanced, that means this is a right triangle. (15, 16, and 31) already in order from least to greatest. 15 squared is a leg, 16 is a leg, we'll square that, and 31 is the hypotenuse. 15 squared is 225, and 16 squared is 256, and 31 squared is 961. 225 plus 256 is 481. This is not a balanced equation, so this is not a right triangle. This is the same as number 6. 8, 10, and 12 in order from least to greatest. So 8 is a leg, and 10 is a leg, and 12 is the hypotenuse. So 64 is 8 squared, and 100 is 10 squared, and 12 squared is 144. And we add those two together, squares of the legs. 164 is equal to 144. Not a balanced equation, so this is not a right triangle. All right, the very last one, 9, 12, and 15, already in order from least to greatest. So 9 is one of the legs squared plus 12 squared equals 15 squared. 9 squared is 81. 12 squared is 144. And 15 squared is 225. 81 plus 144 is 225. This is a balanced equation, so this is a right triangle. So we established on the first thing that we did, from this one right here, we've got side lengths of 3 and 4 and 5. We established that that was a right triangle in the Pythagorean theorem, a squared plus b squared equals c squared. So I wanted to show you that multiples of a triple will also be a right triangle. For instance, if I take each of these dimensions, 3, 4, and 5, as side lengths, legs and hypotenuse, and I multiply it by 2, and I get 6, 8, and 10, that is also a right triangle. And if you don't believe me, let's do it down here. 6 squared plus 8 squared equals 10 squared. And we've got 36 here, we get 64 there, we have 100 here, and if I add 36 and 64, that's 100. Multiply by 3. So 3 times 3, scale factor of 3, is 9. 4 times the scale factor of 3 is 12. 5 times the scale factor of 3 is 15. This is also a right triangle. So let's double check it and make sure it actually works. This is 81. This is 144. This is 225. And when I add 81 and 144 together, I get 225. That is also a right triangle. You could even multiply by a large scale factor if you really want to. Let's multiply by 20, scale factor of 20. So 3 times 20 would be 60. 4 times the scale factor of 20 would be 80. 5 times the scale factor of 20 would be 100. If I substitute those into the Pythagorean theorem just to double check and make sure it works, let's see what happens. 60 squared is 3,600. 80 squared is 6,400. And 100 squared is, what's that number? 10,000. So 3,600 plus 6,400, we get 10,000. So it works. So here's another triple that we have over here. 5, 12, and 13. So let's make sure this actually works first. 5 and 12 is equal to 13 squared. So 25 is 144. I think this is the example that we had. It's 169. So this is 169 equals 169. This is a right triangle. So we could also have multiples of this one. So we can multiply by a scale factor of 2. We get 10 and 24 and 26. If we try that out, this is a balanced equation, so this is also a right triangle. So the multiples of triples are also right triangles. So that's just something that might help you out. You might be able to see that relationship there. So if we go over here, I'm hoping you've seen this one enough to know, have it memorized, that if we have two legs of 3 and 4, our hypotenuse is 5. And we actually just did this one in the pink over here. So the missing leg is 5. All right, 7 and 25. Let's look and see what we can do with 7 and 25. So we'll have to do 7 squared plus we don't know the other leg, and 25 squared. So this is 49, and this is 625. So I'm going to subtract the 49 from here. From both sides to keep my equation balanced, and b squared is equal to 625 minus 49 is 576. Then I square root both sides to keep it balanced. And the square root of 576 is 24. And the square root of b squared, remember these two actions, these operations undo each other, so this is leaving us with a single b. So the side length here is 24. Here we're looking for the hypotenuse. So 8, 15, and we don't know the hypotenuse. So 8 squared and 15 squared are our legs, and we do not know the hypotenuse. 8 squared is 64, 15 squared is 225, c squared, and then 64 plus 225 is 289. Now we're left to square root both sides to keep it balanced. This is 17. And this is a single c. So it's 8, 15, and 17. And we'll put 9 in as a leg, 9 squared, plus, we don't know, b squared, equals 41 squared. 9 squared is 81. And then 41 squared is 1681. We're going to subtract 81 from both sides to keep it balanced. We are left with b squared equals 1600. And now I square root both sides. I square root both sides to keep it balanced and also to find out the value of the single variable b. These two actions undo each other, so I'm left with one single letter b, and the square root of 1600 is 40. And we're going to follow the same process for the next one. And then the last one, we're actually going to use the same process because I have a leg and a hypotenuse. So I can just use what I've used the last few times. So 112 and 113 is the hypotenuse. So I'm going to So any multiple of a Pythagorean theorem or a Pythagorean triple is also a Pythagorean triple. So side lengths of 40 and 75. And then we've got side lengths of 14 and 50. So we've got to find the third side and tell whether it is a leg or hypotenuse. So do you see anything up here where we could multiply anything to get side lengths of 40 and 75. I would have to multiply this by 10 to get to 40, but 5 times 10 does not give me 75, so I don't think that one's it. But what if I take this and multiply 8 times 5, I get 40. 15 times 5, is that 75? Yes, it is. So I have 8 and 15, and this last number is 17. So I multiplied by a scale factor of 5, and I got 40 and 75. So those two are legs. So then 17 times 5, the scale factor, would be 85. So this is a scaled copy right here, leg, leg, hypotenuse. This is a scaled copy of this one right here. So then let's look at side lengths of 14 and 50. I see this one right here. This one jumps out to me. 7 times scale factor of 2 would give me 14. And if I take this and multiply it by 2, I get 50. So we have here a leg. This one's the leg, and this one's the hypotenuse. So 7, 24, and 25. 25 is the hypotenuse. And if I multiply by a scale factor of 2, I'll get a side length of a leg length of 14 and a leg length of 48 and a hypotenuse length of 50. So the missing side here was a leg, whereas here it was the hypotenuse. So this one is the scaled copy of this one. That's all we have for today. Thanks for listening.